As the students gained more experience analyzing patterns, they had a question. Does a pattern always have to begin at the first column? In the example at the top, some students noticed that the pattern seemed to begin with a partial chevron, and a few students wondered what would happen if they added a column before or to the left of column 1 on the pattern, which they referred to as column 0, and whether this would change the pattern core. The rest of the class then explored this line of inquiry. They discovered if a column was added to the left of the core and the new column was considered the beginning of the core, then the whole core shifted to the left by 1 column and comprised columns 0 to 8. They continued to add columns to the left of column 1 and noticed the core shifted by as many columns as were added. However, they also noticed that the number of columns in the core did not vary. For a 3-color 3-bead chevron pattern, the core was always made up of 9 columns. The students identified that any 9 consecutive columns in the pattern could be considered the core, and that identifying the first 9 columns as the core was arbitrary since the pattern could extend to the left as well as the right of the initial given element. However, the width of the core did not vary. In the bottom example, students began to be able to perceive that any 4 columns could be considered the core of the pattern. Again, the important idea was that the core was made up of 4 columns but could begin anywhere. Students decided that it is the number of elements in the core that must remain constant, but that the core can start anywhere. They also played with the idea of going backwards to column 0 and potentially to negative number columns. This is an interesting way to begin to think about other quadrants on a Cartesian grid. The idea of a shifting pattern core seemed to be a new idea for these students, as previously they'd never been prompted to consider that a pattern can extend to the left as well as the right of the given elements. This allowed them to recognize that the core of a pattern is not necessarily defined by the first set of elements, and that what remains constant is the size of the core, in this case, the number of columns.